is now talking about loop engineering, and for a very good reason. Humans need to stay more out of the loop in agentic workflows. With loop engineering, we enable agents to keep working towards a goal and refining things in the process and minimizing the human intervention. Of course, I think this is great and a step towards what we need to be achieving more and more with AI agents and making those agents autonomous. The problem that I keep running into is that I'm not really getting out of the loop when building my own agentic loops. I'm actually often doing more and more work around them. And the more capable that the loop became, or the more stuff that I wanted it to do, the more maintenance I had to do to keep it running, and refinements and checks and everything that I needed to have it working properly. This also brings me back to when I started experimenting with harnesses such as Hermes and OpenClaw, where I thought it would not really be that useful. And even though it was super useful, the amount of work that I had to do around it to maintain that system was not really worth the amount of value it was giving back. And I'm not going to go too deep into why these systems in loops can quickly become a maintenance nightmare. Now, of course, I'm using the Venice API for all of this, which saves me a ton of headaches on model and provider configurations, which you absolutely are going to face if you are working with these harnesses across multiple different models, tools, and multiple different modalities. So I'm not even gonna get into that on this video, because even after removing all of that complexity, the problems didn't really come from the models itself. It came from the agent not being able to reliably analyze, fix, and learn from their own mistakes inside the harness. Even though loops allow for agents to recover from some failures, it doesn't often allow for the agent to understand why that failure happened, whether it has happened before, and if it's something that the system needs to change around to make that not happen anymore. So just back when we were talking about prompt engineering, when we figured out that the way that we talk to the model can majorly improve how the model speaks back to us, and we tried to engineering our way into better results, it did not actually remove the engineering part of talking to the models. Just in the same way that loop engineering does not remove the entire engineering aspect of you trying to talk with the models, and the human intervention is always still necessary to keep building and working with these systems. We're just really moving the engineering work one level higher, and instead of babysitting the model, now we're babysitting the loop. There's also a missing layer problem here that I'm not really sure we're talking about enough, which is the prompts can tell the model what to respond, and the loop can tell the agent to keep working over time. However, none of these layers are defining the agent itself, the agent identity. And this part matters much more than we give it credit to. An agent that has an identity and understands what it knows, which models and tools it can use, what other agents are in its environment it can work with, or what is it allowed to do, and how it should behave across different loops maybe, or inside its own loop and across tasks and conversations. That is a big part of the conversation on building agents and agent harnesses. This is a real gap right now that we at Venice are working towards closing, which is creating these explicit agent configurations that knows what their purpose is and what they are meant to do, so we can eventually create those complex systems with these entities around them that have a proper identity. So instead of personally implementing every part of the harness, you can define what the agent or the mind is, give it instructions, give it models, tools, knowledge, whatever you need, and connect it to all different capabilities through Venice, so these agentic minds can work across every single modality, call all different sorts of tools, and act as a single entity of knowledge that you can plug into those systems. Now, this is just a little tease. I cannot show you the entire things that we're doing for minds yet, but this is coming soon, and we're going to be talking about this probably in more videos in the future, so stay tuned for that. But I do think they feel an important gap in this progression. So prompt engineering is about prompting and improving a response. Minds are about shaping the agents, and loop engineering is about shaping how the agent works over time. Now, a mind still leaves the human in charge of the designing system. It just allows much more of that design to happen through intention and configuration instead of infrastructure. But once the agent becomes explicitly configurable, a much harder question becomes possible, which is who should be responsible for changing the configuration when the system repeatedly fails. And while building my own agent, I kept coming back to this question on what if configuration is not enough? Maybe the next problem is not really building better loops. Maybe it's building systems capable of improving their own loops. And this is not really a new question. Over the last few months, several papers have been made discussing some versions of this idea. And one that I found the most interesting is called the self-harness that improved themselves. And its core observation is that just as a model behavior is not determined only by the model, an agent behavior is not determined only by the model or the prompt either. It's also determined by the harness around it. So that includes the tools, the routing, the memory, the recovery policies, all the verification rules, the permissions, and everything. If you change the harness, that exact same model or agent can behave completely different under the exact same prompt or even under the exact same loop, right? So instead of asking a human to continually improve that surrounding system, what if the agent could participate into improving it as well? And what would that look like? So these are some of the questions being explored here in this paper. It's a super interesting read, and you should definitely read it if you want to learn more about this topic. But one picture that I really like that they bring up is this 3 separate distinctions of what these systems that we're building currently look like. I feel like this is a very interesting way to look at the problem. And the first question that it's asking here is really who is improving the harness around the agent. And this first panel is called Human Harness Engineering. Agent operates inside a system, but a person designs that system. And I would even say that what we currently describe as loop engineering is still involved here in this first loop, even though you could argue that maybe also somewhat the second loop as well. But loop engineering doesn't really remove the human entirely from the process as I see. What it really removes is the need for the human to direct every individual action inside the loop, but the higher level design system still comes from us, right? So we decide which tools exist, we decide how the agents should recover and what the agents should even remember or how it should be evaluated. And when something goes wrong, we are also inside that same panel just driving the fixes and making sure that the system can recover. And what we have here on the second panel is what the authors call the meta harness. And here another agent sits outside the target agent and improves the system on its behalf. So you can imagine a stronger model or a stronger loop observing a smaller model, identifying the weaknesses and proposing a better prompt or maybe a better tool description, rule, workflow, or whatever. But the most interesting part that is being covered here is this self-harness, which is basically what we're going to be talking mostly for the rest of the video. And it's where I currently feel that the industry is leaning towards. Currently, these agent systems that sustain themselves, and that could very, very much look like a self-harness, which basically the authors of this paper describe it as, in the self-harness, the model itself participates in improving the harness through which it operates, but that requires more than an agent capable of performing the original task. It also requires an outer layer capable of understanding how the task was performed, and the system studies how the model behaved under the current harnesses, identifying repeated failure patterns, basically proposing a bounded change to the surrounding process and then testing whether that change actually produces a better behavior, sort of like an evaluation process. They also go on to explaining in much more detail what that would look like. And you can see here a very interesting diagram that you can take a look on the harness proposal in the entire system. And we can see more work and other research papers arriving at similar conclusions. And another paper that we can cite here is this Continual Harness Online Adaptation for Self-Improving Foundational Agents by Seth Carton, which basically talks about the idea of a continual harness, and it describes a progression in 3 stages. And we can see the image here of what it looks like. First is this human in the loop, where the human reads the agent's trajectories and manually rewrites the harness. Then an automated refiner begins doing that work, updating the harness while the system is still operating. And eventually the most ambitious version that they propose here is this, where the model and the harness learn together. And even though the details are different from the self-harness paper, the direction that they are taking here is very similar. This is also another read that I really recommend you to do if you're interested in this topic and want to understand more how the industry is thinking about the next steps here. But all this is very interesting, and even though I think most of the people would agree that eventually this is the direction that the overall agent systems are leaning towards, I wanted to see what this would look like in practice. So I started building what I call Gondola, which is basically attempt to achieve something in the direction of what would be a self-harness. I started building Gondola a couple days ago as a small experiment to test these ideas, and Gondola is not trying to replace the existing harnesses by any means. It's just basically picking up components that we are learning throughout this process and adding to an agent orchestration process to see if it can create a system that can recover from its mistakes and keep a learning process going throughout its existence. So the main agent for Gondola, and you can see more about how it was built and the capabilities that I added to it here in this GitHub repo, and of course the overall architecture that we're gonna get into. The central architecture bet with Gondola is that recovering from a mistake and learning from a mistake is not the same thing for an agent system. And right now in loop engineering, we are trying to recover from mistakes, but not yet learning from them. And here we can see the architectural diagram, sort of the system that was built. A bunch of these things are only possible to be made in such a robust way because of the Venice API integrating all of these tools into one single place, so that I don't have to do that annoying setup of having to connect to multiple providers up front. I just paste one key and that's it, and I can have the entire agent working just as any AI chat application that we have today with all the capabilities. And then we can get into the architecture and how we're thinking about this actually working. And mainly here we have two loops of execution. So we have the inner loop and we have the outer loop. So the inner loop here is actually responsible, we call it a entity in Gondola, and it's responsible for doing the work, right? And the outer loop here, we call it the Gondola lab, is responsible for understanding how that work happened. So here, entity writes the code, creates the media, talks to you, searches, etc. And Gondola lab here that we call has a different job, which is not necessarily trying to complete the task at hand, but understanding, okay, this process that we're doing here, is it working? Is it optimal? If it's failing, why is it failing? Have we had failures like this before? And should we, get enough evidence to create a change here? And of course, the system becomes more robust the more that you interact with it. And we have the inner loop talking with the outer loop constantly about what's going on with it. Honestly, the way that I see it, this outer loop today is mostly being done by a human. And this is the part that we're trying to remove the human from the loop. Whenever the inner loop breaks, we have the supervisor here that tries to recover the current execution instead of just, allowing the entire workflow to end. And the outer loop begins after those executions to produce evidence. The traces for what happened is sent to the Gondola lab. The lab looks across what happened, search for recurring patterns to create possible challenger configurations. And if it proposes a change, it actually makes sure that change actually performs better. Most of these changes are still protected as the system is just born, so it's still going to require human approval. But the idea is that the system grows to eventually not ever need a human to approve after it has already gotten enough feedback. So installing Gondola is super simple. You just need to follow this little tutorial here, and I'm going to be using it here as a web companion. So you just need to run npm rundev after running the installation here. And I've already been using it actually for a couple days, And let me open a new chat here and just experimenting with what can be done. A few things that I think is worth mentioning before we get into is that every single feature that you're seeing right here that Gondola can do is being powered through the Venice API. So things such as dictation, file parsing here for attachments, even things such as voice to voice, but even such things such as personal memory systems. The Gondola Lab itself also uses the Venice API and Venice tools to be able to function. And we also have here one dashboard where I can track all my API calls and spend in one single place, which is very convenient. So this is one of the reasons why if you run Gondola for the first time, the first thing you're going to see is a little introduction box for you to paste your Venice API key, just so that you can get your entire environment set up without having to deal with the hassle of setting up like all these different things. So right now, this is the only requirement to get Gondola running, is just getting the Venice API key, and you're going to be able to have access to all of this system. So the first experiment that I want to do here with Gondola is to give our agent here, I named it Gary, we're going to give Gary one vague and creative goal and see how it deals with it. And I already have it here, the goal that I want to give to it. And it's basically to find recently released open source AI projects that is technically impressive, useful to developers, and has not received attention it deserves. I want to have it research at least 5 candidates, compare them, choose the strongest candidate, and create a 60 to 90 seconds video explaining the project, what the project does, why it matters, and so on. So this is a quite complex task that requires many tools. It requires reasoning, web search, video generation, evaluation, revision. So we're going to see how the system deals with that. And for this first experiment, of course, failure is not necessarily a bad result. We're just testing how the system actually behaves. We're going to be using GLM 5.2 for this one. And while the run takes place, I'm going to be showing you guys a little bit of the Gondola Lab, which is what we talked about being the outer loop and how it works. So here's pretty straightforward now. The Gondola Lab is constantly watching over my system and seeing where it can propose improvements to what I'm doing. So these are the current experiments that I adopted from previous runs. There's just one here really, which is generated images were animated without inspection or approval. So basically it gave me this feedback here in the Gondola Lab where I could understand where it took that feedback from, and I could approve this new harness change and modification. So now every time that images are generated and animated, basically turned into videos, I need to inspect them first. There are more things such as abilities, which is when the agent can call and create an ability for itself. For example, the ability to analyze papers in parallel. So I requested this in one run and the agent noticed that, hey, I don't have this tool available yet. How can I make this tool available? So it created this ability, and I can see this here on the Gondola Lab. And it allows me to have a much more clear view of what's happening across the entire system. This also helps us understand whether the orchestration decisions are actually making sense, or if the agents are just creating sub-agents because they think it's something that they are supposed to do. So here we can see our agent is still working on the task. It's currently searching the web. We can see the step by step. Let's give it a bit more time to come with our proposed answer. It hasn't run into any issues yet. And ideally, if it does, then it's going to report this to the Gondola Lab and it's going to be able to analyze what went wrong and so on. All right, the system stopped running and we have our first failure, which is a good thing because then we can understand how the system behaves around it. So Gary did a good job up until creating the script overview. After that, it got stuck on this use skill issue. And I'm going to basically ask him what happened and can you fix yourself? Can you explain and fix it? Oh, okay, so the error now is more clear. So the model meant to call the tool generate narration to build the video, but instead it called the tool use skill, which only loads skill instructions and does nothing for narration. Then why that skill, that tool broke? That's another question. Let me fix this properly now. First, I'll set up an execution plan so the runtime can track every step and recover if anything else goes wrong. Now, this is pretty good. It's understanding what happened, it's trying to fix itself. And even though I did have to intervene, I mean, this is only the first few runs that I'm having with this agent, so it still has to learn how to behave from me in a way. And I wonder if this is also something that we can eventually remove from the process and have this sort of gondola lab, or really this outer layer, human outer layer, completely already generated, and we can already plug that into our systems without having to do this process of training the system to understand what we want from it. Okay, so browser use was the pick here from our model on open source projects that has not received the attention that it deserves. I do agree that browser use is an amazing project and it does deserve more attention. Browser automation is becoming increasingly more important with these agent harnesses, and to be fair, I'm probably going to be integrating browser use in Gondola if I keep building on it, because it's such a necessary tool for agents these days to just be able to do browser automation, right? Oh no, it's generating narration with our TTS models. However, you can generate the narration sort of natively in the video itself, depending on the models, and it usually works better. I don't know about their choice here. It's just generating the narration itself and sending to me.
Most real software lives behind web pages, CRMs, admin panels, legacy tools with no API. When you automate them, you write brittle code. Break one selector and your script dies. Browser use fixes that. It's an open source Python library where you describe the task in plain English.
Okay, so first thing that Gary did here was to send us the narration for the video. And it's good to know that it can actually send the file in a way that I can actually listen here in the chat. I hadn't really done this before or knew that it could do that, so this is good to know. And Gary's still working, probably generating the video, so let's give it a little bit more time. Videos can take a bit longer. Okay, so 3 visual concepts for the video here that Gary's sharing with me: the AI hand on the browser, code to cursor, or the machine readable web. Okay, so Gary first created this image and he's now going to animate the image into a video concept. Now, the video that Gary's currently creating is only 10 seconds and I asked for a 90-second at least video. So I'm gonna see how it's gonna deal with that. Also, it generated a very long narration that it won't be able to place within this 10-second video. So I'm really trying to understand here what's currently doing. Okay, we need to confirm to create the video here because it's almost $2. All right, so Gondola has reported our goal as achieved and reported 2 issues that I can see here: generate video tool lacks consent parameter and raw API workaround invisible to UI, and it has completed the video on the document/browser use video folder. It did not send the video here. I think this is the second issue that it's talking about. And if we go here to the Gondola lab to whatever it has flags, here you can see what it said: compose media and verify media fail with etc. Basically, this is not allowing to share, I think, the video on the UI, and generate video tool has no consent parameter needed for the seed as face image to video models. Okay, this is super interesting actually, that it managed to flag 2 problems, and we can see here that the fix for these problems has not been drafted yet, but I believe this is going to be addressed by the Gondola lab as we go into the next experiments and as we continue to use the tool. I don't know if there's a cron job for that specifically that I set, but it's amazing to see that this is working as expected, to be honest. Let me allow here. It's asking for some permissions. It's asking for a lot of permissions, really. I think I was not really too permissive when I set this up, so we can see that happening a lot. Okay, so it generated these files. So there's the scripts, there's the social posts, captions. So let's see the video. Okay, so the video is actually 1 minute 24 seconds, which is honestly great that it actually followed my instructions like that.
Most real software lives behind web pages, CRMs, admin panels, legacy tools with no API. When you automate them, you write brittle code. Break one selector and your script dies. Browser use fixes that. It's
made a
an open
loop
source Python library where
with
you
the same
describe the
video.
task in plain English. An AI agent opens the page, clicks,
It's
types,
not
and extracts
super
what you
bad,
need,
right?
the way a human would. Instead of hard coding selectors, like it
At
turns
least
the
it
live
didn't
page into a clean,
spend money with
machine-readable view the model
loads
can
of
understand.
new
Then
generations.
decides each next action on its own. It even ships browser-trained models.
Now, this is very interesting. So it just created this loop with the same video, but I'm actually very impressed that it managed to create this .mp4 file with all these videos, the same video, but even so, like merged together, and even put the audio layer on top of it. I honestly didn't expect it to be that clever. So yeah, I'm very pleased, and it even reports that the goal was achieved here for me. Now, I feel like this was a very successful experiment. We found the failures. We got the lab to actually report back to us, which is amazing. And it's very clear that as I am using this system day to day, that the amount of work that I will be doing will be diminished as I keep working on it and explaining how it should use the same tools. At least I won't be really seeing the same problem twice, which is already amazing. Of course, Gondola and especially the Gondola lab are still very early. It currently only understands a few failure patterns, and many of the evaluations right now are simplified. The recovery system is nowhere near where I want it to be, and I still don't think we have really figured out the correct relationship between the outer loop and the acting layer. But this is precisely why I'm sharing with you guys and building it in public. The more I built Gondola, the more I realized that I wasn't really implementing this with a bunch of answers. I was really figuring out the questions, as cheesy as it sounds, and honestly some very philosophical questions that I came across that I did not expect. For example, should an agent understand what it is? And the reason for this was that one of the most common failures that I kept running into was that the agent was not having an accurate understanding of its own capabilities and what it was able to do, and it kept asking me for external approval and validation. And perhaps this is something that is currently baked into the models themselves. Even so, you currently show the model and give the model the tools. Sometimes if you don't guide it the right way, it doesn't feel confident enough to use them. It also lost track of asynchronous jobs that it was running, maybe because it wasn't really told to be looking for those. And what I found is that what we would call a less intelligent model with the access to the proper tools and capabilities would perform much better than a frontier model such as Fable 5 or GPT 5.6 that weren't told, weren't given this identity beforehand. So this is just how much this really affects the output behavior of these models. Another question is whether really recovering from a failure and improving the system should even be handled by the same intelligence. For example, if an agent gets stuck halfway through a workflow, which would happen often, maybe it should focus entirely on finishing today's tasks. But if the same failure happens 10 different times over the conversation, maybe that's no longer the responsibility of the acting agent at all. Maybe it's something outside of its power. And of course, this is where the Gondola lab should step into the system and really figure out what's happening. So how much freedom do we want to give the actual acting agent on top of their own harnesses? Where should we put that freedom so it can rewrite itself, or maybe rewrite just a tool, or maybe rewrite its system prompts, or change how memory works? Or should it simply collect the evidence for everything that's happening and allow the other part of the system to do the work? And as I was experimenting, I found that the lab, because it's still not very well optimized, often failed to catch a bunch of these recurrencies that the agent, the working agent itself, actually was very quick to act on. But as the system gets more complex, that relationship becomes increasingly more delicate. Now, this is also where minds become especially interesting to me, since minds will give the human a place to explicitly define what the agent is. So everything from identity to tools to capabilities to memory and how it should behave, and to what extent do I allow that system to interfere within main infrastructure, right? So similar to how people work in companies, depending on the people doing the work, you're not gonna give it access to the same tools or the same level of permissions. Of course, I don't really know how much of this process should be explicitly automated, automated, but having an explicit configuration layer gives us something much more concrete to inspect on and evaluate, inversion, and govern than a harness that's scattered across like a bunch of prompts and codes and tools that you don't even remember anymore. Like I said, I don't think Gondola is the next generation of agent harnesses by any means, but I think it can become a starting place for us to begin to explore what can come after loop engineering and how to remove the engineering from the loop altogether. And maybe some of these ideas will turn out to be wrong, and maybe we will discover parts of the engineering work that should always stay human, but maybe we can automate the whole thing and let these systems behave as living entities. I'd love to see more people build systems like this that helps us investigate those questions and help us get to the next level of agentic systems rather than, just pretending that we already know the answers. Gondola is completely open source if you want to try it. Contributions are super welcome if you want to see more improvements being done there. And if you want to inspect the code, break it, fork it, feel free to do so. The link is going to be below this video. Mines are coming soon for public release. We're very excited to put this out there, which is really next step towards building more capable and independent agents. And yeah, I think they're going to make this entire conversation much more interesting.